Tá? So, hi everyone. My name is Leo. This is actually quite nice to be back in the Barcamp. I think the last time I was in one was about 10 years ago in Coimbra. So there is a long-standing tradition. We were just talking about that in Portugal of Barcamps, and it's nice to see that they're back, and in Lisbon, which is a bit more convenient. So I'm here to just give you a very quick overview of what the technology behind Observador looks like. Okay, so obviously not time to go in depth about me. So I'm the technical director at Observador. I also run a product for media companies called Frames, and then there's some other projects I've been involved with in the past. But about the newspaper. So the newspaper is only 5 years old, so it is relatively young compared to most newspapers who have sometimes 100-year legacies and transform from paper to digital. We were born digital. So 2013, before the actual launch, I was involved in the UX and UI part of the newspaper, and the rest of the company was trying to set up their own .NET bespoke content management system and website and everything. And ultimately, that failed, the .NET part. And, well, not the .NET part, I'm being unfair. What failed is that they tried to do something from ground up, a new CMS from scratch, the bespoke bit. And we ultimately decided in a quick sprint, in about 5 weeks worth of work, to launch the whole website using just WordPress. So that fixed it, and we launched in May 2014. And then 2015, we got the award of the best media launch in Portugal, voted by the media experts. 2016, we started to feel some growing pains with WordPress, as predictable, and we started to decouple some features from WordPress. So typically user-generated content, logins, comment systems, were the first two obvious candidates that needed to go. 2018, we were voted the best newspaper in Portugal. And 2018, we also introduced our premium subscription platform. So most of you will know that newspapers go through a little bit of a crisis when it comes to monetization models. And ultimately, almost all newspapers are understanding that ads are not enough. And it is time also to actually ask readers to pay for the content they read. 2019, we were again for the second year in a row, made us very proud, voted the best newspaper ahead of Público, Expresso, other leading newspapers in Portugal. And we also launched a radio, both online and with a full podcast offering, but an actual FM frequency radio in Lisbon and Porto, which is also an atypical move. We're going from digital to analog instead of the other way around. One other thing we did in 2019 is we started to offer, as a first in Portugal, and there's only a handful or two of newspapers around the world that do this, we started to offer subscribe with Google as a method to pay for our premium content. So instead of inserting your credit cards and using other payment platforms, Google is now offering, just like Apple News they have their offering and Facebook has their subscription offering, Google now has this subscribe with Google option for you to use a Google Pay account to actually access content, not just on our website, but on their Google News and their AMP platform. So just to put this into a perspective, this is how big we are now. We have about 240 people every day producing content, so journalists. We have about 200,000 articles published in these 5 years, 1.5 million images, and adding everything up over the last 5 years, we served about 2.5 billion pages, which nowadays looks like 40 pages per second served to readers. But of course, the problem isn't the 40 pages per second. The problem is all the requests that come with each page you make. So when you visit an article, what you see is the article, but in the background, there are subscription validations, there's image requests, there's logging authentications, there's systems to put this in your reading record, all kinds of things. So I just want to split this into 3 parts: the team, the architecture that serves the content, and then the architecture that handles all the other services that come with this. So the team is a team of 7, though we're down 1, so we're hiring, hint. And we have this funny coincidence actually having 2 Alexandres, 2 Alices. We're probably going to hire a Nuno by this trend. I don't want to be discriminatory there, but so then comes the content bit. So the reason I split content from services is because they're literally split in two different services. This is all on Amazon Web Services, and all services are on Google Cloud. Okay, so there's a literal translation and separation. And the reason the separation exists is actually historical. This is how we started on Amazon with our WordPress setup. And then when I mentioned before that we started taking some services out of WordPress because it doesn't grow as well, that's actually moved over to Kubernetes on Google. So this is the origin, but it's still the core of what is editorial content. We basically have native apps that consume our APIs. We, of course, have the browser. We have APIs that feed content to other systems. And we have, of course, a lot of RSS feeds. All of them hit Cloudflare. And then from there, the requests that go to Google go out. And I'll show that in a second. But the other ones go forward and either get served directly from our S3 bucket with static assets. So images, CSS files, all kinds of stuff. And then the load balancer forwards it to our EC2 containers. They're just normal Linux containers that just run WordPress and can scale horizontally. The data, of course, lives in a database separately. We use Aurora, which is a great drop-in replacement database for MySQL. It shows great performance improvements over MySQL. MemSQL may be something for another day to try out, but this serves us well now. And then we have two more helpers, very convenient helpers. One is, it's a typo, it's not Elastic Cache, it's Elasticsearch. Elasticsearch basically allows us to search through 1.5 million images without using SQL queries in WordPress, which doesn't work. So this allows the journalist to just type words and immediately out of the 1.5 million images find the one that talk about the right persona, the right location, the right football game that they're looking for. And then Redis over there is our cache repository. So we cannot possibly 40 times per second rebuild every page that the user asks for. So what we do is for a minute that page lives copied and ready to serve again in a cache system. That cache system is not on Redis, it's on the EC2 instances. The thing is we have an in-between. There's a little in-between moment which I'll talk about in a moment, and that lives in Redis. So the point of the cache is, as I said before, to serve the same thing again and again without having to reprocess it, obviously. The thing is there needs to be a middle ground. Here we have full rebuild of the page. Everything has to be recalculated. I have to get the name of the author, the email of the author, the categories, the color of the categories, the text and the images, and calculate everything together, related articles below every time. So that's when there's no cache at all. The full page cache is I take all of that, save that result, and serve it over and over again to people. The problem in the publishing industry is that news typically have very short-lived, and there's typically a lot of breaking news and breaking the cache. So every time something changes in the website, we want to be the first serving this information. We cannot afford 60 seconds of just having information and not giving it to the user. So what we build is an in-between layer of cache, which WordPress doesn't do out of the box. So we sort of have our custom code in front of WordPress, which is basically a WordPress template, but with a lot of object-oriented PHP taken very far. And we build our own objects saying, look, this article and all of its surrounding information belongs in this one little piece of cache. And then we can very easily say, if any editor touches that article, then break the cache of this article only. So there's a little middle ground between everything or nothing that actually allows us to have some sanity on the database without going crazy. So this is the list of our microservices. Microservices, I'm not sure if everyone's familiar, but very simply put, instead of having one big software piece that has to deal with everything, we cut it down into multiple little applications, little software pieces, and each one is very specialized in one simple task. And that allows, of course, two very important things. One, maintainability, where that piece of software can be rewritten and optimized very easily without having to redo everything. And the second bit is you can allocate the right amount of power in terms of servers to the piece that needs it, right? So this is the reason we use Kubernetes for this, to manage which piece of this gets how much power depending on what happens throughout the day, you know? If there's a live log happening, you have some servers that are under great strain. If on the other hand, there's a big discussion going on in the comments section, there's other services that get a lot of load. So we have multiple servers here. I won't go through all of them because that would be very time consuming. We have one right in the middle down here called Orthographical, which is like, it's a spell checker, basically. But it also serves another purpose. Many of you might have noticed in many newspapers there are typos. And it's very frustrating to read an article and feel that the journalist didn't have the time to write properly. There's always an excuse, which is a time pressure, and they have to produce very quickly to be the first to give the news. But what we did is we allowed anyone who works inside of our newsroom to, while they read the website on their devices, to just double-click a word and change it, and it saves the correction. So you don't have to go into the back office, edit the article, change it. Because often we know they see the error, but it's just the effort to go back and fix it, they'll go like, nah, let it be. And so we created a little dashboard. This doesn't exist publicly. This is an internal dashboard. We call it Orthographical. And it basically scores the users by who corrects more and gives them like a little prize. Makes it into a little bit of a game to, hey, who corrects more and who did the latest corrections to incentivize this. So this, for example, is one of the microservices that you saw back there. One very complex thing we deal with is payments, of course. Whenever it comes to payments, everything changes because one mistake is a phone call and a refund and real numbers that put a cost on every bug you produce. And here's an example of a few platforms that come into play whenever we deal with a subscription on our website, right? So the flow is typically a user comes to a website, wants to read an opinion piece, and it says, hey, you have to pay. 999 out of 1,000 people don't pay, we know that, or open incognito, though that doesn't work anymore. And so ultimately one says, okay, I want to pay with subscribe with Google, which is an external platform. This is by Google, this is their API and their JavaScript framework that runs on our website. They pay. We have to listen with our microservice that someone wants to pay, and we have to check if that user exists on our website. So we get entitlements, we see if that Google account exists on our website or not, we have to calculate this. And then we have to forward it to another microservices of ours, which has a separate responsibility, that only takes care of access, so access to content. Does this user already have an account with us? Is he trying to pay again for something he already has? Is he renewing? Whatever he's trying to do, porteiro, which is translated to gatekeeper, has to understand who goes through the gate or not. That forwards it then to Piano, which is again an external platform. So Piano, for those who work in the publishing industry might know, is the leading software for paywalls. So metered paywalls, you have X articles left for the month, that kind of stuff, that's Piano. Sorry? It's horrible, agree. So, this is on video, I forgot. Anyway, it's great. It's fantastic. I mean, horrific, it's great. I think that's the word. And so Piano is our central source of truth to know who paid for what and for how long they can read the access, but it's on the server side, right? And so we forward it to Piano. Piano has to synchronize information. And then from Piano, hooks are triggered to Analista, which is the analyzer. And Analista, all it does is take information from this different system and spit them out ultimately into our Grafana dashboards where we can see what's actually happening, how many subscribers we have from the different source and everything. And ultimately, it also pings our invoicing software, which is also external, to then ultimately send the email to the client who bought the subscription saying, here's your invoice for your subscription. Because Piano, not being a Portuguese company, doesn't do a tax-recognized invoice for Portugal. So this is a nightmare to manage, obviously. We're quite proud that we do manage it for the team size that we have, and we like to keep it very, very quick, and we like to be very quick on our feet in actually intervening whenever something like this happens. Key for this is having reporting, of course. You can't find any mistake if you don't have a lot of reporting. This is half of the island where we work on. And of course, we have screens with dashboards trying to inform us of what's happening. I'll show a close-up. No need to zoom in. This is the Kubernetes reporting system. So we typically can see what's happening. There are very normal curves throughout the day. By the way, everyone reads news while they're at work. So that's lesson number one. Weekends are flat, nights are flat, mornings are flat, but work time goes up and then lunchtime down. So second dashboard is the WordPress insight. So this is basically the content. As we're serving content, what happens, right? How many requests per minute? 4,300. So I assume it's going to be more than 40 per second. I mean, must have done that math wrong. Load balancers, CPUs, memories, backend response calls, all kinds of stuff. And then very, very critical, and this is like the one thing that can fail in any system, is the database, of course. So we also have a separate dashboard just for the database. A little piece of advice for those of you who do use the RDS service, the database services on Amazon. This is not as new news anymore. It's been around for probably more than a year now. They have a nice feature called Performance Insights, which basically shows you over any time scale you want which queries were done most times and which ones of those are most heavy cumulatively. This is very interesting if you're using a software like WordPress or Drupal or anything else where you don't have control over the queries, but you rather need to understand which ones are heavy and how to optimize how you use those features to not produce any weird spikes. There's one there that this stuff might produce. That's it. The website, of course, is observador.pt. My Twitter handle is LXVR, so if you have any questions or comments, feel free to hit me up on Twitter. Thank you.